Hi student, I am back again. Today we are going to cater to two very important topics, and that is classification of elements and periodicity of the properties of elements. So let us begin with the first one, that is classification of element and periodicity in properties. So we begin with the first question itself. The important question: the first ionization potential of sodium is 5.1 electron volt. The value of electron gain enthalpy of sodium ion will be. Now this is a very interesting question and a very simple one. Let's see the solution part. The first ionization potential of sodium, what does that mean? It means sodium atom loses one electron and turns into sodium ion. It turns into cations by loss of electron, for which the ionization energy is given as 5.1 electron volt. Now they are asking you the value of electron gain enthalpy for sodium ion. Now gain enthalpy means Na plus ion, that is cation, is accepting one electron to turn back into atom. That means it has to gain of electron. Now this is very simple. Now for losing it is 5.1, for gaining it will be reverse, the same magnitude. Only the sign will differ. So the ionization energy, the electron gain for it will be minus 5.1 electron volt. If the ionization energy is 5.1 electron volt, then electron gain will be minus 5.1 electron volt. So your answer for this question is B. Okay, now let's go to question number 2. Question number 2 says the order of electron affinity of fluorine, chlorine, bromine and iodine is in which order? So let's see the solution for it. Now fluorine, chlorine, bromine, iodine, they all belong to halogen family. Halogen family. Fluorine, chlorine, bromine, iodine and astatine. They are group 17 elements. Group 17. Now the question is, electron affinity is the tendency to accept electron. Accepts electron. Among this, the most electronegative element is fluorine. And we all know the one which is more electronegative, it should easily accept electron. Electronegativity down the group, it decreases. So the most electronegative is fluorine. So the first thing which will come in your mind is the answer should be fluorine first, then chlorine, then bromine, then iodine. Astatine is radioactive, so we don't take into consideration. But reality mein, the most electronegative element is fluorine, but it doesn't accept electron very easily. Reason? Fluorine size is very small. Size is small. Since the size is small, the density of electron in the outermost shell is very high, crowded. So when a new electron tries to approach, it repels that electron. It repels it. So in spite of having higher electronegativity, the electron affinity of chlorine is more than that of fluorine. So in that case, your chlorine has more electron affinity than fluorine, and chlorine has more than bromine and iodine, because as we come down the periodic table, the tendency of gaining electron decreases, giving electron increases. So the answer for this question will be chlorine will have higher electron affinity than fluorine as well as bromine and iodine. So your option among this will be A. which is the correct answer for question number 2. Okay, student. Let's see question number 3. Question number 3 says, the increasing order of the ionic radius of the given isoelectronic species. What is the meaning of the word isoelectronic? Isoelectronic means having the same number of electrons. Having the same number of electrons. So you want the increasing order of ionic radius. Okay. So let's see how to solve this question. Solution for this. First and foremost, we are given chloride ion, we are given calcium ion, we have been given potassium ion, and we have been given sulfide ion. Sulfide ion. These are the 4 which has been given to us. And we are supposed to arrange them in the increasing order of ionic radius. Increasing order of ionic radius. And all of them are isoelectronic. They have the same number of electrons. Okay? They have same number of electrons. Now, a very important and a very simple way of arranging such type of question. Don't forget. If the proton, that is atomic number, if the proton is high, then size will decrease. Proton increases, size will decrease. Shortcut way to know such type of question. Just take out the atomic number, that is proton, number of proton. Now in case of chloride, it is 17 proton. In case of calcium, it is 20. In case of calcium, it is 20. Potassium, it is 19. And sulfur is 16. Now look at this. Look at this. What did I say? If the proton is more, the size will be smaller. Among them, who has the maximum proton? Calcium. So calcium size will be the smallest. Proton more, size less. So calcium has the smallest size. Okay. And then potassium is more than calcium because it is 19 proton. And chloride will be more than this. The size of chloride ion will be more than that of potassium ion. And lastly, sulfide. So this is your order of atomic ionic radii for isoelectronic species. So the answer for this question will be C. C is your answer for question number 3. Okay, simple. So let's go to question number 4 now. Among the following, the number of elements showing one non-zero oxidation state: oxygen, chlorine, fluorine, nitrogen, phosphorus, sodium. So what is the meaning of this question? It says that find out those elements which can have only one oxidation state. So among them, how many elements are having only one oxidation state? That's what you have to find. So let us see now. We have been given oxygen, chlorine, fluorine, nitrogen, phosphorus, sodium. We all know fluorine has the highest electronegativity. On the Pauling scale, its electronegativity is 4. Highest in the entire element kingdom. So fluorine has the tendency, it accepts one electron. It will only accept one electron and turns into F minus. So it can have oxidation state of only -1. Okay, so it can have oxidation state of only -1. Whereas sodium is an alkali metal. it has one electron in its outermost shell. So it loses one electron and turns into Na plus. So it has oxidation state of +1. So these two elements have oxidation state which is non-zero oxidation state and can exhibit only one type of oxidation state. So your answer is two of them, among them two. So your answer is B for question number 4. Simple. So let's now move to question number 5. In a given shell, the order of screening effect is. You want to know about screening effect. We all know that s orbital is very close to the nucleus as compared to p, d and f. Screening effect depends on effective nuclear charge. Now since s orbital is very close to the nucleus, it will experience a higher effective nuclear charge compared to p, then d and the last f. So it's a very simple question. So the order should be s will be more, then p, then d and then f, due to effective nuclear charge experienced by all these orbitals. S is very close to the nucleus, so it will definitely experience more effective nuclear charge. So screening effect will be higher for it. So the answer should be S will be more than P, then D, then F. So your answer among them should be A. Very simple it is. This is question number 5th. Now we go for question number 6th from this topic. Which of the following oxide doesn't reacts with both of an acid and alkali? Now we all know the one which reacts with both acid as well as base are called amphoteric. They are called amphoteric. The one which can react with both acid as well as base, they are called amphoteric. Zinc oxide, we all know it is amphoteric. Tin oxide SnO2 is also amphoteric. Aluminium oxide is also amphoteric. Remember, their oxides are amphoteric, not the metal. So aluminium is not amphoteric, aluminium oxide is amphoteric. Now these three are amphoteric, can react with both acid as well as base. But beryllium oxide, we all know beryllium belong to group 2, alkaline earth metal. So it's a base, so it will react only, it will react with only acid. It will react with only acid. So the exception among all the 4 is, yes, you are right, it is beryllium oxide. It is beryllium oxide. Okay, very simple. So we go for the next question now. The strongest oxidizing agent among halogen is. Now we all know halogen. Halogen belongs to group 17. Group 17. And they are asking us which is the most powerful oxidizing agent. You know, oxidizing agent, the one which is a very strong oxidizing agent, has a very high reduction value. So oxidizing agent is directly proportional to those which has a very high reduction value. A reduction value should be high reduction value. At the same time, oxidizing agents are those which has a very high electronegativity. should be high or more. So if you see among them, the one which is highly electronegative, we already know it, it is fluorine. F2 has an electronegativity of 4 and its reduction value is 2.87 volt. Electronegativity 4 and reduction value 2.87 volt, more than any other element in that group. So definitely your answer is D for question number 7. Now we go for question number 8. Okay student, let's now tackle this question. The question is, the ionic radius of C4 minus and O2 minus respectively are 2.6 and 1.4. Then the ionic radius of isoelectronic ion N3 minus would be. Now this is a very simple question. See, all three of them are isoelectronic, and I have told you what is isoelectronic? Having the same number of electrons. So you have C4 minus and you have O2 minus and now N3 minus. They have given you the ionic radius. The ionic radius given for C4 is 2.60, whereas this is 1.40. These are the radius given, sorry, it is oxygen which is 1.40, and they are asking for N3 minus. You wanted for N3 minus the atomic radii. Previously, in the previous question, we have come across isoelectronic ions. In that, what did I say? With the increase in proton, that is atomic number, the size decreases. The size decreases with increase in proton. So I have already indicated to you that as you increase the proton, as the proton increases, the size will decrease. So now let's take out the number of proton, that is atomic number. For carbon it is 6, for oxygen it is 8, and for nitrogen it is 7. Now arrange it according to the size. The one which has the largest number of proton has the smallest size. That means O2 will have the smallest size. Then it will be N3 and the largest size will be C4. Now look at it. The radius of oxygen is given as 1.40 and carbon is given as 2.60. So definitely N should lie between these two. N3 minus should lie between these two, should have ionic radii lying between these two. So now look at the options. Can it be 2.6? No. 2.6 is for C4 minus. Can it be 1.71? Yes. It has to be greater than oxygen and lesser than carbon. Yes, this can be your answer. What about this? No. What about this? No. So your answer for this question is B. Okay student, so I believe you must have got the varieties of question ka taste with respect to your classification of element and periodicity properties of it. So I have covered up different varieties of questions which are likely to be asked. We'll continue with a new topic, very important topic, in our next episode. Till then, see you all, be safe and enjoy yourself.